Okay, so welcome everyone. You should be able to see my screen okay. And welcome to the last TCoffee and Code of the series, and there will be more coming. We've been enjoying the format, and I think the feedback we've been having has been really good from it as well. So this series we've been running on GoToMeeting. If you're watching this on demand, obviously you're only going to be able to see the slides. For those of you who are live, then obviously feel free to put your webcam on and we can all kind of say a virtual hello to each other as we're going through today. Always nice to see some faces. And please go ahead and use the chat as we go through to share and kind of keep the conversation going as we work our way through. So joining me today online for IoT and Data, we have Marco Cantu. Good afternoon, Marco.
Good afternoon.
And Jim McKeeth. Hi, Jim.
Hello. Hopefully my audio and video are synchronized now.
Looking a lot better than it was, yeah.
Awesome.
So, and obviously, I'm your host, Stephen Ball. This is obviously a topic area that's quite close to my heart, with obviously the work that I've done with InSpace in the past, and also with my time at Nokia for a few years. So let's get straight into where we are going. Oh, before we do, the replays, obviously, just grab the replay link here, bit.ly.tcoffee and code replays, and that'll take you directly to the Embarcadero TechNet YouTube channel and to the playlist for the TCoffee and Code. So I think I kind of commented at the end of last week, I think I might have bitten off a bit more than I can chew to try and squeeze this into half an hour, and we might need to follow up with some slightly smaller, in-depth topics. So, but wanted to kind of give it a quick shot, just to kind of give an overview to the world of IoT and data, and a number of the different things and considerations that as developers we need to be aware of and thinking of as we go through and put together applications to work in the IoT space. And obviously IoT, Internet of Things, really about the world of connected devices. But beyond that, looking at how connected infrastructure is playing a big part of that, because they say like the new oil is the data, but that data is worth nothing unless you're doing something with it. So really want to kind of have a look at the different components and things that fit within the whole architecture and ecosystem as we kind of run through today's session. So I think we'll start off. Jim, Marco, please feel free just to jump in any time, but I want to start off really looking at where data is processed. And when it comes to the collection of data, the first part of it is actually collecting some data. And that can be done either right on the edge, so where the sensor is, and then it's where, what you do with that data then. Do you process it locally? Do you move it back centrally? Where should you be storing the data through?
That's a really interesting thing, because some people don't think about the amount of data you're collecting with these things, right? And so, you kind of probably want to do it both at the edge and the central, because if you do it all centralized, you have to transfer a ton of data that you may end up never using, I would think, right?
Absolutely, and this is the case. Think of temperature sensors. So we've had this whole thing with the Suez Canal in the last week. Billions of dollars worth of trade bottlenecked through through the Suez Canal, not being able to move. If you've got on board medical supplies in containers that are sat out in temperatures that are rising, you need to know that if they've got a window where they spoil, you need to know that stuff has gone off before it gets to its destination now, so you can ship the next batch to replace it. So in terms of the data that's being collected there, you want to be monitoring it, and you're going to be checking that maybe every 20 seconds, 30 seconds. But you don't want to send all that data back centrally. That's kind of a waste of data to move, bandwidth costs. What you can do with that data, you store it. So you do want to do some local edge processing. And quite often you'll see kind of array buffers being pushed together to get the minimum, the maximum, and the average temperature over a period of time to then push the consolidated data packet back. But also, what you're storing to disk locally, there's so much that you need to do in memory, and there's also kind of the level of redundancy that you need to write stuff down. So it's getting that balance between what is important to keep versus what is transient. So having things like temporary tables to work with and temporary storage is also very important for logging and processing stuff through. Because as you said, Jim, getting that data and making it useful, that's the kind of the key thing. And especially if you start looking at some of the architectures, modern architectures around things like AI, what you need to be doing is engaging with the data scientists up front to understand what data points they need to be able to consolidate down to put into data models. Because typically a data scientist is not going to want to work with petabytes of data. They're going to need to consolidate that down and summarize that to a level that they can then feed into the machine learned algorithms. So if you can do some of that pre-work ahead of time on the edge when you're collecting it, then that saves a whole load of centralized processing that you've got to do, which may have a different cost and occurrence. And also down to data storage as well, because the storage of data, storing a gigabyte compared to a petabyte of data has a cost implementation over the long term as well. And if you're only going to be pre-processing that data to get it down to, say, 1/100th of the data that you've actually got centrally, then why have all that cost through the whole supply chain? Eliminate it where you can at source.
Right. Yeah.
So, okay, let's think now. We've got an idea about data on the edge, collecting it, pre-processing it, thinking about what we need to do with it. Obviously, the one thing I would say is if you've got any sensitive data, then you need to look at things like GDPR and data encryption and the storage of that, making sure that it's encrypted at rest, which is the main thing. And especially on kind of cheap IoT devices which are easily hacked. Quite honestly, it's quite often an easy thing to take some of these kind of maker boards or anything else like that and and have a go at them. If they're not very well locked down, you need to make sure that the data file is well encrypted. But you got the data now, you've got to move that data somewhere. So this is where the whole kind of layer of connectivity comes in, and there's a lot of considerations around connectivity, and primarily, especially on IoT devices, it comes down to the battery. If you think about a maker board that's deployed out, one of the stories I really liked from my time at Nokia was this work that was done in New Zealand, where they had problems with areas flooding. And what they did is they ended up creating IoT sensors to put into the drains. And those IoT sensors were then measuring the depth through reflection of the water below, and then feeding back to a central command point the water levels. So if it became an early warning system of kind of either drain blockage or something more sinister to worry about, and to kind of start rerouting and reflowing water, which obviously has a major impact in terms of supply chains and roads and railways and all the other kind of stuff if they start flooding. So, but the key thing there is you're not going to have a mains power supply in a drain. You need to be running these off battery. And when you start looking at devices like that, it's what's the cost of to the battery? Where's the big cost? And typically it comes down to the connectivity. So things like Bluetooth or Bluetooth LE will have a low cost in terms of the battery. A 5G connection is going to have a high cost on battery, because 5G works as a technology in a very different way with a handshake and connections than an offline, I'm still here kind of technology works. So that's why we've seen things like NB-IoT evolve, which works within the LTE spectrum bands. So basically, the way the 4G works today, for example, the bandwidth that's being used, which is spectrum, its owned license spectrum. So as a company, you have exclusive use to that spectrum. They basically chunk it up into, say, 20 chunks, and then use that to then distribute out for the LTE networks to make the scale work through. So what they do is they reserve a couple of blocks or one or two blocks out specifically for the NB-IoT, and they then work that in a slightly different way. So instead of having the physical handshake and the connection that maintains, as you would do with a cellular phone, the connection happens, and it's almost like right, I remember where you were and roughly what's going on with you, and then there's complete disconnect. And that way, because you've not got that connection, you've got that drop in battery usage. And then later on, at the point that the cycles run through on the device, it will just do a little fingerprint just to say, hey, I'm here. And it kind of maintains that kind of footprint. So the cost of battery is kind of a big thing. And so Spectrum, when it's owned and managed, you've got a clarity in terms of signal. When you start moving into things like Wi-Fi or stuff that works in what's known as scientific spectrum ranges like LoRa and Sigfox, anybody can deploy something out there. And the range of a LoRa, Sigfox, or MBIT signal can be, in ultimate conditions, about 10 kilometers. In typical conditions around a city, probably around about 3 to 4. And that allows for kind of deep underground penetration of those signals. So if you've got lots of things fighting against the same signal stuff, that can have a degradation on the battery as well, because you're then fighting to be heard over the other things that are running around you.
So you're looking at your connectivity, you probably have like the Bluetooth or Zigbee would be like the immediate things right around the device. Yeah. And then you'd have LoRa and Sigfox would give you like a small area, right? So if you were connecting to things on it, so like Bluetooth would be like right immediately on the device, where it's like just maybe not want to be wired, but then the LoRa and Sigfox would be like covering like your a building or something like that, and then you'd either need to get onto Wi-Fi or using a 5G to go beyond that to a completely different location. Would that be?
Yeah, so things like Wi-Fi, Bluetooth, and Zigbee are localized connections, and they're very good for that. And you see a lot of that with the home IoT stuff. If you're looking at building things that are kind of maybe on the road, you need to be looking at a cellular connection. And the cellular connections, depending if you want to have licensed or unlicensed, have big implications, should I say, for how things can work. But they have much bigger range. So things like a pet tracker, your home Zigbee network or Wi-Fi hub that's plugged in is not going to be able to track your cat if it's gone 2K down the road. But something that's running off a LoRa signal, would do that quite happily. But they're not the kind of things that you would set up yourself to run. You wouldn't necessarily from home set up a LoRa network. That's something that you would subscribe to and have the infrastructure there. And that's the kind of thing that the telcos are looking to put in place to make sure they're available. And which kind of brings us through to kind of things like Wing and the IoT Alliance. So Wing is this kind of global partnership network, where network operators have come together to share spectrum in different geolocations to enable to have a global SIM card that you can buy that can then be tracked and used everywhere. So if you think of the shipping example we were talking about earlier, when you're out at sea, they would need to have a localized network on the ship because there's nothing going to be reaching that. It's only satellite in terms of your backhaul. But when you get near to a port, then obviously there's going to be localized cellular networks that your devices can connect up to. So having a single SIM that can work globally through transportation, all these different things is something that is coming out now. And this is important, especially in things like cars. There's a big push for this within the automotive industry, having a global SIM card that can be used anywhere where your car is, to be able to get the analytics and everything back for the servicing and all the other kind of advanced features that they put onto cars nowadays, which is kind of cool. So,
how does that with the? I was just thinking about the you're talking about the battery and stuff like that, and that really plays into mobile as well. So if you're working with a mobile app that you want to be aware of how often you're using the battery or what you're using the battery for to maintain the mobile app battery, The same sort of idea, right?
Yeah, no, absolutely. Every connection, every push of data, every cycle that you're pushing and pulling stuff has an impact on the device that you're running it on. And wherever you're doing something locally, that's just using the local CPU. That's using kind of a small amount of battery, in essence. When you're using the chips to do the remote connections, because those connections have to be kind of shouted from the phone, and depending on how close it is to the cell mast as well, will depend on the cost to it. So that's why Wi-Fi has a much lower cost on your phone battery than your cellular connection has when you're out and about, because the phone's having to shout that much louder to be able to make that communication happen. And the louder you shout, the more energy you use, basically.
Yeah.
So
I guess once you have the data and you're connected, you got to figure out how to move it from the edge to the central location.
Yeah, and consume it around as well.
Yeah.
So there's either pull or push mechanisms in place, but also it kind of starts. This is really where developers can start adding a huge amount of extra value beyond just the device sensor location, tracking stuff. Because even if we can't do some of the bits that we want to do with the devices today, we can use things like Arduino and Visvino. The name, Jim, Visvino, is it?
Visvino, yeah. Visvino is the visual Arduino IDE development system. Yeah.
So there's some great connectivity things for linking apps there back to RAD Studio and to components and so on. And if we can do some of the bits there with the devices and then start looking at how we move the data around, it's then really about how you get notified of those changes and how you also packet that data to move it. And there's a load of different kind of models hitting the market now. Each have their benefits depending on what you're trying to do. So on, one of the kind of the methods is to just kind of push all the data directly up to a middle tier, and then have the middle tier do something with it. So the middle tier almost just acts as a gateway, a doorway for that payload to be delivered. So you can do that easily with something like RAD Server or DataSnap or a web service, or even it could be as simple as an S3 bucket that you're pushing data up to, which I know a lot of AI guys use because it's actually very fast in terms of the file movement around. But once you've got the data up there, you need to be able to kind of put it somewhere to make use of it. So things like streaming platforms, where you have on the server side a publisher which it basically says we've got a number of different channels of data that's coming through. And then it makes that data available. And then as a subscriber, you can subscribe to that data and pull down from specific channels of interest the data that gets come through. So that's quite often used with AI models because it's quite a good fault-tolerant way to stream a whole load of data through. And if you do have any kind of breaks, you just kind of go back to where you were within the stream to kind of carry on pulling the data through. So things like Apache Kafka are a great model for that. The other kind of one is kind of the Google Cloud pub sub model, which similar kind of setup and configuration. This is used with subscriptions for Google Play, for example. So if you want to do in-app purchases by subscriptions, you need to set up a pub sub model where the pub sub data is pushed into, and then you need to set up your middle tier to then subscribe to that and pull that data down so you can then know that somebody's subscribed. And then in your middle tier, you can then set up the subscription stuff. So when they're connected back in with the phone, you've then got the active subscription managed, and which is why it's kind of a lot more complicated than a standard in-app token purchase. But again, that's a useful model. And then we kind of start looking at things like real-time databases, like Firebase, which is basically a JSON data store with key value pairs. And there's some interesting stuff out there in terms of you have to be really aware about how you're putting your data structures together if you're using something like that, because otherwise you end up having some really large JSON packets that are trying to be pushed around, which can be an absolute killer. So you have to be really, really precise in the way that you set up and configure your data for doing that kind of stuff. Or the other kind of part of it is things like change views and interface, where you're able to push in the data and it just goes directly into a normal SQL table. And then we have this method for setting up subscribers to data. And then you just connect in with your subscription ID and run your SQL statement, and you get at a field level what has specifically changed, which is absolutely amazing. That's way beyond some of the other kind of technologies and what they can do. So there's a number of different kind of bits in kind of the whole moving of data to think about.
Yeah, I think another angle is the format you're using to move data around, because yeah, there are some that are easier on the developer, whether it's XML or JSON, which tend to be extremely inefficient in terms of the overhead. I mean, XML being notorious because you have open something value and then the close tag, which tends to overload. But I mean, all of these formats tend to favor readability and flexibility in terms of processing, but are a total disaster in terms of the bandwidth they consume. Now, in some cases you don't care, but in some cases you do care. And so going for a more optimized format, whether it's just BISON, the binary JSON, or it's some other even nicer format, or whether you take whatever you have, JSON or XML, and you just zip it, because they tend to compress very well.
Yeah. And
so you're just sending a payload, which is the compressed version of the content you want to transfer. It's not trivial, because it's another area where something that is apparently simple and an obvious, almost obvious decision, hey, JSON is nice, let's use it, it might not scale the way you are expecting.
I remember a BoreCon session I went to, Marco, that you were speaking at about XML and databases, and talking about the fact that if you take an XML file and split it up into the database, and then later try to pull that back out into a document that you have, I mean, that's kind of there's talking about the pros and cons of that. And it got me thinking about the fact that sometimes, you have things that are not symmetrical, right, if you will.
Sure.
So you think about that, you're grabbing data and you might say, oh, well, these parts are interesting, let's put these in a table. But there might be other things in that data that is still interesting as well, that's going to vary from item to item. And so the idea that sometimes you might want to keep those as an XML file or JSON file or whatever, in beyond the way it's stored in the database. And I guess that's where databases like MongoDB, for example, come into play as being more interesting for that, is that you can do it as a, you don't have to have the same exact data row to row.
Yeah, and that's one of the things, especially as requirements change with IoT data. NoSQL is something that is quite often looked at as the format for storing, and also kind of seeing a hybrid. We're seeing more and more now that people are looking and going, right, actually we need to think about which part of the technology stack is right for the specific job that we're doing, and hybriding, the use of SQL because it has benefits in certain areas versus NoSQL, and using the bits to link and that's one of the great things about having a middle tier behind where your device is connected into. You can actually augment and change and move data between different places quite easily without having to redeploy and manage the updates down to the devices. And that's one of the key considerations around architecture, is that the storage of data should be completely transparent to the end point that's out there, because going ahead and changing 10,000 devices that you've got out there is not a trivial manner. So much easier to be able to kind of update the way the data is being stored back and processed than to kind of push it back the other way around. So absolutely kind of a middle tier architecture within IoT is also is just a critical thing. And I think that's also why we're seeing a lot now of what the term for microservices, where we're seeing that actually more and more people are looking at going, right, well, this is a specific functionality of something that we need to do and we need to build, and this is the best way to build that, and getting that built and having it available. but also using open innovation to look around and go, well, actually, they already built this. It does exactly what we need. So why would we go and rebuild and do something else when we can get this at a manageable cost and have a world of development and experience being fed into the improvement and the maintainability of that, and be able to build on top of that as well as part of our ecosystem underneath. So seeing this kind of pool of microservices now is a very interesting kind of architectural approach.
It's interesting. I remember when the idea of a middle tier kind of started getting popularity, and I was like, what? Why would you not just talk straight to the database in your application? But now I've gotten to the point that it's like I always want to have a middle tier, right? That makes sense. I understand the utility of the middle tier, but microservices are basically that same idea, right? In building on that, and so it's again, it's not what we're used to, but when you realize it is the evolution, if you were, of having the middle tier, then it makes more sense. And so it allows you to have that decoupled as services as well as decoupled in your code, right? I remember back when objects were introduced in your code, you didn't just have global variables and global, routines. So, it's that same sort of idea. It's that evolution of the decoupling, if you will.
But yeah, I think the middle tier, I've often built middle tiers before in the past that have always been kind of almost a bit like a set of microservices by breaking up the functionality to have them very, very loosely coupled, that I can lift chunks of them and use them in other systems very quickly, because that gives you the functionality that you need. Having a microservice to manage users and email registration and that kind of side of things. Why would you want to build that every single time? You go and you pick up a meat that's got that embedded in it, and off you go. It's about building, taking the bits that you need and building on top of them to make it quicker and easier.
Well, I get people all the time ask me what's the difference between RAD server and data snap, and really that's what it comes down to, is that RAD server has those reusable bits built into it, right? Data snap is the kit for building the services, and RAD server is, already has some of them ready to go for you.
Mm-hmm. So one of the other things that I've seen quite a lot now, obviously, is there's a lot of talk around AI. There's obviously Watson's been around for a long time with IBM, which you can easily access into with a bunch of web services. I know Al Manarino's done some sessions on that before, but also with AI, there's a lot of models that are now being put together, and Python is a very popular language within that space for developing and prototyping and putting together AI models to work with the data that's been collected and brought back. And I've seen things where we were talking earlier about battery life and looking at the cost to a specific device of the connectivity side of things. I've seen stuff where AI engineers have been working on looking at cellular data to understand which devices are getting close to the point that they need to have their batteries replaced, and understanding if there's, for example, an issue with connectivity within a certain area, where you might have different cell masts that are overlapping the coverage areas. You can end up with kind of a conflict happening between the device that's in the field and where it's trying to talk to, and that can have a real immediate impact in terms of the battery life. And if you think for some of the larger deployments, it's going to cost you $70 or whatever to go and replace a battery on a device in the field by the time you send somebody out there to open it up and change it over and put it back down. If you've got 1,000 devices out there, that's $70,000 just to go and change all the batteries. And the difference between that being done every 5 years or 10 years compared to every 6 months is a colossal cost in terms of the infrastructure that you're looking at. So being able to kind of track and monitor these type of things is kind of a key thing. And where, going back to kind of the AI side of that, being able to take the data that we have around and use those for something useful. Quite often data scientists are working in Python because it's quite an easy model, language to use with it. There's a lot of examples around a lot of the kind of models that have been put together. But some of the challenges they have there is the speed and performance of Python when they're trying to work with it. And especially when they start kind of going from their sample data and checking it to then running it on much larger data sets, the speed bottlenecks become a major, major issue. And that's really where you need to start looking at the native performance of AI and having code that's optimized to run on the hardware. There's a massive, massive difference between the basic number crunching that you can do in Python compared to a compiled binary that you produce out from RAD Studio, for example. Go on, Jim.
I was talking to a developer that uses the Python for Delphi bridge because it said that what they do is they take advantage of the breadth of libraries that Python provides for data ingestion and machine learning and stuff like that. And then they use Python for Delphi to integrate that into their system. But then what they do is when they see a specific use case that they're seeing frequently, they then rewrite it in Delphi to get the optimization they need for better performance. So that the Python gives them the breadth and flexibility, but then they use Delphi to get the performance where they see bottlenecks or they see paths that are happening a lot. And that kind of gives them the best of both worlds, which is really interesting. And that's the great thing about something like Python for Delphi is Python for most use cases is used more like an integration tool than as a general purpose programming tool, in that you use Python to connect to these libraries, and those libraries are often written in, or the high performance libraries are natively compiled. They're written in a native language, whether it be C or even Delphi. And so you use Python to connect to these libraries that have the performance. And so you can actually use Python for Delphi to connect straight to the libraries, bypassing the Python bottleneck, if you will. So it's an interesting situation that you can be in for that, for sure.
So I guess that kind of really brings us on to the developing and data. Obviously, one of the really interesting areas, we've spoken a bit about big data and AI and these kind of different infrastructures and bits. But I think containerization and things like Docker have had a big change to the way development can be done. And I think for developers now, Malcolm Groves did a really cool session looking at using Docker when you're doing database development and being able to pull down and run and spin up a Docker instance of a NoSQL database or MySQL or whatever, just to be able to say, right, I've got it there, to deal with something and then just ditch it afterwards. And the ability to then reset that container and run the same thing again and again makes it really useful for unit testing and testing specific code elements that have been put together to get those kind of done. And I know we've now got containers for Docker for RAD server as well, haven't we, Marco? There's some pretty cool stuff there.
Yes.
So the other kind of thing really from the development point, when we're looking at cross-platform usage and consuming and using kind of the data that's being generated across multiple different platforms, and also being able to visualize that data, because quite often one of the key outputs of any of this kind of sensor data or IoT data is a visualization dashboard somewhere. That's really what makes sense of what's going on, and is the quickest and easiest way for people to make sense of it. So things like a T-chart and those kind of libraries, and there's also a few nice web ones with infusion charts and those kind of programs as well. If you're putting something up onto a web page, for example, that's a great way to be able to kind of get stuff pushed out and around.
See, here's an interesting comment, Marco. Maybe you can help answer. So Alexandra is saying, DataSnap, you have callbacks, which isn't the case with RAD server. So Can you do a callback with RAD server, or is that only a data snap type feature?
No, that's only a data snap type of feature. It's based on the fact that when you make a call within an HTTP, you make an HTTP request, you can keep it open. So rather than making the HTTP is stateless. They make a request, you get a response, done. Now what can happen, you can make a request to send back some response, but you don't complete the request, so you have a communication channel that remains open. Then in theory, either side can use to push some further bits on the socket. Now it's fairly tricky, and it is a smart idea. It has a significant drawback though, because it suffers from unstable connections. You need to maintain the connection open. So it's something that if you're on a local area network, it's great. If you're on a remote internet, can be worked out. It might have some firewalling issues. If you're on mobile, that's really a no-go, because while you always have connection, it's not a stable connection over time. But it was a nice feature. And in some cases it makes a lot of sense. So it is actually quite powerful compared to just continually pinging the server from the client or to see if it's still up and running. Now, RAD server has a different architecture, which is also quite interesting, which is basically a reverse call architecture. We call it think points because it's actually meant for IoT, but it is actually a bit more. It's fairly sophisticated and can be used in many different scenarios. So conceptually, a client can tell the server, hey, I'm here, need to expose an IP. Hey, I'm here, call me whenever you need information. So let's go back to the thermometer example. You can have a model where you have a thermometer that pushes data to the server every second, minute, hour, the average of the day, whatever, depending on the application scope. And then suppose you have your mobile device and with another client. So the other client want to ask, hey, give me the last temperature. And it's going to ask the server. And the server says, hey, the last I received is this temperature from a second ago, an hour ago, whatever. Now with the think point mechanism, the device that has the sensor connected can tell, hey, I'm here. This is my IP address. So when the client comes in and asks the server, hey, give me the temperature, the server can say, hey, let me ask. So the server will make an HTTP request to the client through a specific port and socket and IP, and the client will send an immediate result. So it does like a full round robin. Client asks the server doesn't know, goes reaching the device, making a specific request, receives back the information and sends it back to the client who was asking. So it's kind of triangulating the information. This is very powerful because conceptually, it means that your server is going to have additional URLs, additional entry points for the devices that are actually connected. So what the device does, adds an entry point to the server, a list of available URLs, and that entry point is something that's going to be redirected to the device. It's a very powerful mechanism, and it's very flexible. It can be used way outside of this IoT scenario, which was what it was invented for. I think we have very little code and demos around it, which is a bit unfortunate because it is a powerful technique. Because the idea that you have an individual server and someone can register and say, I can make information available and then there is a discovery mechanism, so you can query the server which of the URLs that are available. You can get a list of what's available, and so you can build some very flexible architectures with endpoints that come and go, because of course the client can also say, hey, I'm gone, I'm not available anymore, it's going to unregister itself. So you can build some very dynamic architectures that certainly serve IoT, but would serve other cases in general.
Yeah, I remember sitting with Jim Tierney, who was working on that originally a number of years ago down in Scotts Valley, and seeing his whiteboard stuff kind of work around, and the light bulbs that were going on. Oh wow, look at the different scenarios that you could bring into it, and it really comes back into kind of this, where is data processed? Data is processed out on the edge, on time, just in time. It's like, right, I need this data now, and it gets it now, and that's then pushed back through to the central architecture, which then distributes back out. So there was a question in the chat about, would this work in a web browser? Well, because there's an application that is the thing point application that is deployed locally, this enables you to have a Bluetooth connected device that is then part of a centralized REST URL that you can access, which is just bonkers. It's absolutely fantastic. And because it's only ever communicating at the point that you need the data, in the scenario that Marco gave there with the thermometer, you've got somebody comes in, they need to have their temperature taken. The battery life on the device is kept optimal as well, because it's not having to constantly be collecting, monitoring, and managing kind of the data on the edge. So a really kind of unique architecture and a very, very powerful one.
Yeah.
Cool. Okay. So I think just in the interest of time, let's just kind of move on. I just kind of wanted to sum up from our conversation today, and to kind of look at a few of the different areas that IoT and data are kind of facilitated within what we offer from Embarcadero. And also we've kind of mentioned Interbase, RAD server a couple of times today. Obviously Interbase, with its very small footprint, is ideally suited for deployment out on a whole host of different devices. It's a couple of meg, a few meg for the actual the lightest part of the database. And as we know, we can deploy that on Windows, Mac, iOS, and Android, and Linux, and Mac OS. So there's a number of different kind of distribution models that we can use with that, and that provides exceptionally secure data security for storage on disk at rest, which is critical if you have any high risk data that you need to store. And also, it's kind of
Well, I would add to that.
Mm-hmm.
Honestly, you should assume all of your data is high risk. It's so often, especially if your data, there's so often that people have things that they don't think is important data or not risky data that they don't secure, and then later it gets compromised, and then they realize, oh, this does have personally identifiable information when it is cross-referenced or whatever. And so this day and age, secure all your data at rest, secure all your data in transit. There's no reason not to do it, especially once you start to aggregate data together, because you could have something in there that's got a header that happened to pick up a header off somebody's phone that walked by or something, and all of a sudden now you've got personally identifiable information on somebody, and if that gets compromised, you're looking at a fine for each individual person. So it's not worth it. Just secure everything.
Yeah, so and that's one of the things now, having, especially in the enterprise edition of RAD Studio, Interbase to Go, completely runtime royalty free. There's no excuse not to secure any of the data on a mobile device nowadays. The other thing, we've spoken a little bit earlier about change views in terms of the data movement. When it comes to IoT and the movement of data, the shortfalling of a lot of replication types of technologies comes down to the fact that having multiple destinations, if you're moving data back and forth especially, becomes just an absolute administrative nightmare. And that's one thing that we're having complete logless change tracking at field level within Interbase means that it really is a super secure way to track changes and also to be able to distribute them out in a very unique way with the briefcase model and being able to keep briefcase data up to date as well, and by being able to find and identify exactly what has changed since you last fetched that data. Obviously, on the Rad Studio side, we've got some amazing connectivity with FireDAC for connecting to key SQL and NoSQL databases. There's we spoke a little bit about using Docker to be able to pull down and set up lots of different databases and to be able to connect across to those, and that's a great way of being able to do that. Just to set them up and bin them afterwards. I kind of played with that for the first. Well, I remember when I played with that for the first time after watching Malcolm's webinar. I was just like, I literally just got MongoDB up and running in about 5 minutes. I didn't have to set up an OS. I didn't have to set up the whole database platform. Literally spun it up, got the connection, and I was reading and writing data directly from the IDE. It's just like, wow, okay, this is amazing. And also, things like a lot of the services and microservices today are built on REST. Things like the REST debugger, which you can pull from the tools menu in the IDE. It's a fantastic way to quickly just check your connectivity and then just copy the components across into your application and off you go. One trick that I've found, I've quite liked putting a data module together with the base connection and being able to have some base classes for initializing that kind of connection, and then having a number of different data modules that inherit from that, which I then put the connectivity for each of the different services that I'm calling from it. And that works as a really nice way to then be able to have a single point to update if I need to move from one service provider to another, but equally just be able to then split my functionality out in quite a nice way and still use kind of the the non-visual components and all the other kind of bits to be able to convert the arrays, JSON arrays, into data sets, and to be able to work with those really easily and to have that kind of shared functionality to pick up what's happening in them.
I love the REST debugger and that copy components functionality. And I have a fun story I'm going to share really quick. Is I was traveling, I can't remember where I was honestly now, but I was traveling someplace, and one of the local reps was like, "Oh, I met this guy for lunch. He's a C# developer," and ran into him, and he's running a C# shop. I went to school with him, but I thought it'd be great if you come by and talk to him. I'm like, okay, sure. So I go by to visit with him, and he's running a C# shop and was building this desktop server, traditional type software. But his CTO just came and said, "We need a mobile app." And so he's like, "Mobile app?" And so he looked and said, "Well, Mono is Xamarin gives you the ability to do mobile with C#." So he's like, "Okay, I know C#, so I'm going to try it out. I'm going to give myself a month to develop a REST client, simple REST client." And he said he was about 3 weeks in, and he was not making any progress. And I started to smile, and I said, "I bet you I could make a mobile app in 5 minutes and deploy it in 5 minutes." He's like, "No way." I'm like, "Yeah, I bet you I could. I haven't done this yet, but I'm pretty sure I could." And so I went in with the REST debugger, connected to the REST service, defined how I wanted it to look, copied components, put it on the form, dropped a list view, live bound it, and deployed it. And it was just over 5 minutes, but he was like getting his phone out and he's like, "I can't believe this." He's taking pictures of it the whole time and just could not believe how productive I was being with that. So anyway, if you haven't checked out the REST debugger yet and what you can do with that, it's amazing. The enterprise connectors are like pre-built things for, like, if you're connecting to like Twitter or something like that, that's fantastic. But when you're connecting to something that's not in the enterprise connectors, the REST debugger is just so invaluable for that sort of thing.
And Marco, do you want to just take us over some of the RAD server bits there?
Sure. Well, I think the Elias has a very good list. The RAD server can really be handy if you need a way to create a simple multi-tier solution that uses open and public, standard endpoints, standard JSON, has metadata using Swagger, and provides in the box some of the core features like user management, user groups management, push notifications, and so forth. It has built-in inbuilt analytics, which is always nice because you can track, what people are doing. Again, no extra work to be done there. Overall, it's a powerful architecture, but if you're using DataSnap, I mean, you can continue using it. DataSnap works, although it's not as modern and as open to different type of clients as RAD Server is. RAD Server has a couple of nifty things in addition. One is the beacon fencing, which is the ability to create an indoor map using beacons, and then have operations like kind of check-in, check-out, or tracking an individual device, which could be a phone or a beacon device, within a closed area, whether it's a warehouse, it's a shopping mall, it's a museum. We have a few use cases of people using beacon fencing for museums. And so it's a nice small add-in to the core product.
Yeah, I like the beacon fence because it kind of flips the whole Bluetooth connectivity on its head and makes the Bluetooth the actual location sensors for the mobile device to then actually be able to say, I'm at this point, can you give me some data about this point? Which is absolutely phenomenal, being able to track in and out of specific zones and have events happen as you go in and out of zones and so on. It's a very, very powerful technology, and I love the museum use case with people as they kind of get from place to place. Okay, so obviously kind of a little bit conscious of time. If you haven't got the latest RAD Studio yet, then obviously just a reminder, go to my.embarcadero.com to download the latest version if you want an update subscription. If you don't currently have an update subscription, then you can go to the trials page and just go to embarcadero.com and follow your nose. You'll be able to find it pretty quickly. Click on any of the products, and there's a try for free now link. And
actually, I'm going to make a plug for 10.4.2. Just everybody I've talked to that switched to 10.4.2 is just ecstatic about it. The compiler speed and all the improvements on there. There was one of the, I think it was TMS Software. One of the developers there said he was just testing it and the speed was so much better. He's like, usually I wait a while to switch to the new version, but he had to switch immediately because it was just so much better. The performance improvements, productivity were that much better that he couldn't justify still using 10.4.1. So highly recommended.
Mm-hmm. Just a quick shout out, if you are watching this on demand, then it would really help us if you would just like, subscribe and share. It really helps us in terms of understanding which content is you're enjoying, and so we can make some more of it around that area. So. Great, so just finally, before the end of March, we do have kind of an end of financial year for Idera. There's a couple of extra offers that have been thrown in as an extra 10% off on top for the Enterprise edition, and up to 40% off on Interface. So if you're liking the idea of maybe getting some of the change views or other kind of technologies inside your server side, then that's definitely worth having a look at. You can feel free to reach out to anybody at the Embarcadero team, and we'll be able to help connect you up to the right people. So that really is it for today. So just as a reminder, if you want to kind of catch the replays, please head to the TCoffee and Code replays page, or kind of if you have any further questions, please feel free to reach out to any of the panel from today's session. Thank you everyone for joining us. Thank you for the chat that's been running through. See, that's kind of really picked up in the session. Thank you, Jim, for joining us. I know it's very early for you, and also Marco as well for joining us through the series as well. If you have any other ideas for sessions that you'd like to dive into more deeply, or that you'd like to see covered in the TCoffee and Code in the future, then please feel free to drop any of us a line. Just first name dot last name at embarcadero.com, and we look forward to seeing you next time we're on air.
Oh, hopefully the next version of RAD Server will have the ability to send coffee over the internet.
Yeah, that would be nice.
Yeah.
We need to put a feature request in. Anybody know the product manager? All right, guys. Thank you very much for joining us. Happy coding, everyone. See you soon.
See you later, everybody. Bye-bye.
Thanks. Bye-bye.